Hi folks, I have another lesson for you today on just calculating simple heat questions. So our simple heat calorimetry question where the substance is given or the energy is given or the mass, specific heat capacity and the change in temperature is given and you can find heat. So let's say we have a question. I'm just going to pick a question from here. I have a bunch of questions here. Pick one at random. So let's say we have the amount of heat. So let's down. So find the amount of heat, which is represented by the letter Q, needed to raise the temperature. So needed to raise the temperature of 5.00 grams of a substance. So we don't know what the substance is. From 20 degrees Celsius. So from 20 degrees Celsius, which means the initial temperature was 20 to 30 degrees Celsius to 30.0 degrees Celsius. So temperature is going up by 10. Now, we don't know what the substance is, but they kept on going and they said if the specific heat capacity of specific heat capacity, of the substance is 2.01 grams, joules per gram degrees Celsius. Yes, it's joules. That's the amount of energy per gram degrees Celsius. Okay, so that is the information that is given to us. We are looking for amount of heat, which is Q, when the temperature change of the substance was 10 degrees Celsius and the mass was 5 grams of the substance and the specific heat capacity was 2.01 joules per gram degrees Celsius. So to find the heat Q, we have to find the mass of the substance, which is 5 grams, which we have. We need to know the specific heat capacity of the substance, which is 2.01 joules per gram degree Celsius that they gave us, times the change in temperature of the substance, which they haven't given us the change, but they have given us the initial and the final temperature. And to find the change in temperature, we have to take the final temperature and subtract the initial temperature. So to find this Q now, I can plug in all the values. I have 5.00 grams of the substance. I don't know what the substance is, but that is not important because we have the specific heat capacity already. The specific heat capacity was 2.01 joules per gram degrees Celsius. So now we have that as well plugged in, and times a change in temperature, which is 30 minus 20. So this is 30.0 degrees Celsius minus 20.0 degrees Celsius, and right there. Okay, now let's plug in the values into a calculator and solve for the answer. So 5 times 2.01 times bracket 30.0 minus 20.0, and that gives us a value of 100.5 joules of energy. Okay, so this is 100.5. Now, since the information that was given to us were all three significant figures, and we are doing a multiplication division operations here, the answer should be three significant figures. So we need to round this value. So since we have 100.5 joules, and the last digit is 5, it's exactly 100.5. So we look at the digit before the 5, which is a 0. Since 0 is considered an even number, this final answer will be rounded to 100 decimal joules. So we would not go to 101 because 0 is considered an even value, whereas if it was a 101.5, I would have rounded up to 102, right? So that odd and even rule for significant digits applies here. So the final answer in this case would be 102. and a decimal there. And the reason for the decimal is I am trying to indicate that there are 3 significant figures in the answer. So the final answer here is 100 decimal joules of energy, or you can write it differently as 1.00 times 10 power 2 joules as well, because that also indicates a magnitude of the value of 100 and 3 significant figures.